Okay guys, I'm gonna go through a few problems from the similar triangles packet. Okay, this is my plan for today. I'm gonna go through all of the algebra with similar triangles. So that's gonna be setting up proportions just from word problems and pictures, the side splitter theorem, and the ones with the right triangles with an altitude drawn. Okay, I think that's gonna be enough for today. We can work on proofs for our next lesson. Okay, so I'm gonna get started with the problems. Okay, you should have the chat open up right now and you can chat me in any questions as I'm doing them. Or you could wait and ask me during support later in the week. Okay, so first problem that I wanna do is on page 2. Okay, and that is number 2. Okay, so number 2 on page 2 is just a word problem when you're given the lengths of a triangle. So you could draw any kind of triangle you want, it doesn't matter, and put the 3 lengths, which are 3, 4, and 6, in any spots you want. Now, the most important thing when you're drawing pictures or when you're solving similar triangle problems is lining up the sides as they correspond. Okay, so when they tell us the length of the shortest side of a similar triangle is 5, that has to get lined up with the 3. Okay, and when they ask you to find the length of the longest side, that unknown x has to correspond with the longest sides, because similar triangles, their sides are in proportion, so smallest lines up with smallest, largest with largest. And then it's a quick and easy solve. It's just a little bit of a proportion, right, where we use the sides we have. Now again, it doesn't really matter how you set up the proportion as long as you have corresponding. So what you could do, so what I did in the notes packet is 3 over 6 equals 5 over x. But what I also could have done was 3 over 5, so small to small, equals large to large. And do we see when I cross multiply and solve, I get the same thing for x. So it doesn't matter, again, as long as you have corresponding. So I have small to small, large to large, same triangle, okay? I'd also like to do number 3. Number 3 is a little similar. It gives you 3 sides of a triangle, which are 4, 5, and 6. And then it tells you that the measure of the perimeter, it says find the measure of the perimeter of the other triangle whose longest side is 9. Okay, so now you could find all the other 2 missing sides of this and just add up the 3 sides. But what we are going to learn about, what you probably should have realized about similar triangles, is that not only are the sides in proportion, the perimeters will be in the same proportion, because to find perimeter, you're just adding sides. So if the triangles are in a 1-to-2 ratio, their perimeters are in a 1-to-2 ratio. So not only can you correspond sides with sides, you can correspond perimeters with perimeters. So what I'm going to do is in this little triangle, I'm just going to find the perimeter of this little triangle so I can set up a proportion that is side to perimeter, side to perimeter. Again, it doesn't matter when you're setting up the proportion whether you put the perimeter on top and the side on the bottom, the perimeter on top and the side on the bottom, as long as it corresponds. Okay, you can do whatever. As long as you have corresponding sides, corresponding perimeters, you can kind of set up the proportions in a lot of different ways. So again, it won't matter that once you, okay, except that this perimeter is 15, sorry. Okay, so it doesn't really matter which way you set it up. Once you cross multiply, you do get the same thing and you get x is 22.5 on this one. Okay. All right, so that's just, basic word problems. If we look on page 3 at number 7, the reason why I want to do that one is oftentimes you are given pictures, okay, where your triangles aren't necessarily lined up in the way they are similar. So the picture on this one looks like this, right, where you're given P, Q, and T, and you are given S, R, and T is the other triangle, okay? So the important thing again is to make sure that your sides line up. What you might want to do in triangles like this where they overlap or they're not lined up is actually to line them up how they're supposed to be. So if I start with PQT, okay, so how do I know which side goes with which? Because the way they give you the triangles are similar. They give you PQT is similar to triangle SRT. Okay, so when they give it to you, that means P corresponds with S. So wherever I put P, I have to put S. Q corresponds to R, and T goes with T. So now I'm not going to use this picture anymore. I'm going to use this picture, okay? Because everything is lined up nice. So when I'm given X minus 5 and 5, and I'm going to rewrite the 2 and the X minus 2 here, I can see that what I have clearly lines up, so I can do the proportion on this one. Now, another reason why I want to do this proportion is because after I set up my proportion, again, so that my sides correspond, when I go to cross multiply here, right, we have a binomial times a binomial, okay? You could do that out on the side if you would like, x minus 5 times x minus 2, but realize that is 4 multiplications. So you're going to get x squared minus 2x minus 5x plus 10. So when you combine like terms, okay, you get this, okay? So since this is a quadratic, we have to make it equal 0, right? So we're gonna minus the 10, and I just get x squared minus 7x equals 0. Since it's not a complete trinomial, this one is just gonna get solved by doing a little factoring. Take out the x, you get x minus 7. Don't forget to get answers. So our answers here end up being x equals 0 and x equals 7. Now, oftentimes when you get two answers, one of the answers may not work, and that's the 0 in this case, because if you were to substitute 0 back into here or here, it would give you a negative side. Sides cannot be negative, guys. We know this, so I have to reject the 0. My only answer is 7, okay? All right, so two kinds of theorems happening here, right? We have our side splitter theorem and we have our right triangle theorems, right? Okay, so with the side splitter theorem, let's take a look at that. The side splitter theorem just says when you have a triangle and you draw in a parallel side, right? So just that it ends up being parallel. Okay, so within this triangle, it doesn't matter which way we could draw it, okay? Just parallel to one of the sides if I draw it in a segment. What I end up with are two similar triangles, okay? So the two similar triangles is this top guy is always going to be similar to the full triangle. And the reason being is because all three angles of the top triangle are equal to all three angles of the little triangle. The reason why I know that is I know they share a top angle, and I know because of parallel, I get, oops, sorry guys, I get corresponding angles here. So I know that's congruent to that, and I know that's congruent to that. So what I end up with are two similar triangles. Okay, so I can set up proportions between the top triangle and the bottom triangle. Again, you could separate them if you want. When you set up your proportions, that's fine. You could separate them, but that's the way it would go. Now, as a bonus, we could actually kind of shortcut it a little bit. You also get a proportion between these two pieces on the side, okay? You get these side-to-side proportions, I call them, okay? So that's what's happening. So if you look at number 8, on page 11, right? So that's where we're skipping to right now. So number 8 on page 11 gives you this diagram, okay? Okay, you're given a diagram, okay, where you have, it looks like you have a side splitter drawn in there, okay? Okay, and you know it is because they tell you this is parallel. So because those are parallel, you know you get a whole bunch of proportions. Now it just depends on what you're given, which proportions it is. So you are given that AC is 9. So that's this whole thing. You are given that AD is 3. You are given that CE is 10, and you're asked to find the length of AB. Okay, so this one involves, it's the side to sides, right? It's the side pieces. Now again, the proportions with the side pieces, you could set up a proportion between top to bottom equals top to bottom. You can set up a proportion with top to whole, top to whole. You could set up bottom to whole, bottom to whole. There's 3 different ways you could set up the proportions, okay? So now with this one, again, you just have to make sure you have corresponding pieces of information. I'm looking for the bottom, I have the bottom. Over here, I have the top, which is why I need to find the top over here. So I'm not going to use this 9 in the proportion. I could, but then I would have to refer to this side as 10 plus x, and it just gets a little more complicated. You don't need to on this one. So all you have to do is do 9 minus 3, you get your 6, and now you have enough to set up your proportion, right? So I can do the side-to-side pieces here. If I do 6 over 3, I can correspond them to the same side-to-side pieces over here. So I get 6x equals 30, x equals 5. Boom. Okay? Done. Okay, now sometimes it doesn't involve the side to sides, so if you look at number 7, okay, number 7, I know I'm going backwards with these, but that's fine, right? So number 7, same picture, okay, so I have ACB, and I have this side MN being drawn in parallel. Great, okay, so this time I'm given that AC is 8, I am given that MC is 6, I am given that AB is 12, and I am looking for MN. Okay, so now because the proportions now involve these middle pieces here, right? Instead of, it's not just, I have some side here, but I've got nothing on this side, okay? So this is where we're gonna have to go back up to here and think of it as a part to whole proportion, okay? So remembering that this top triangle, right, whose sides that I have are 6 over x, right, left side over bottom side, is proportional to the large triangle here, right, whose corresponding sides in the large triangle, its left side is 8 and its bottom side is 12. So I have to correspond that to 8 over 12. Okay, so you know you have to do that if it involves any of these bottom pieces instead of just side to sides. So when you cross multiply, you end up with just 9, bam, you're done. Okay, now as a bonus, if not only is this parallel side, so if we go back up to our picture here, right? So if you know that not only, if you draw this parallel piece so that it clips through the midpoints, the endpoints of this are the midpoints. So now I know this is congruent to this. I know this is congruent to this, okay? So what would have to happen is, you see what would end up happening is if I was comparing this left side to the whole side, like I am here to here, do you see it would have to be half? So this little piece is half of this little piece. So it's automatically what it would do. And same thing with this side and this side, right? So this little piece on the right is half the whole piece on the right, which means these bottom pieces are also in the same 1:2 proportion. So this bottom piece is always going to be half the bigger piece, which just means you don't have to know as much when you're setting up the proportion. So if you look at number 6, right? So on number 6, when they give you the triangle with the side splitter, DE thrown in here. So not only is it parallel, they tell you it's parallel, but they tell you that AD is congruent to DC, which means that's a midpoint, which by the way means this has to be a midpoint also, okay? So notice they don't give you much on this one. They only give you that DE over here is 4. And you're like, well, what am I supposed to do? Well, you don't need to set up a proportion because this is automatically a 1:2 ratio. So that bigger side has to just be double, and it's 8. Okay, so sometimes they give it to you like that, like number 10. If you go to number 10, the next page, number 12, sometimes they give you it 3 times. They make this little triangle within a triangle, right? Okay, sorry, I just want to line you guys up here. So they'll give you a triangle, and then they'll do 3 midpoints, and you join another triangle, okay? So what you know is you've just got these, so that would mean this side is half the side it's parallel to. This side is half the side it's parallel. This is half. So what you just end up with is this little triangle, which is going to have 3 sides that are half the bigger sides. So it's just going to be a 1-to-2 proportion between the smaller triangle and the bigger triangle. Okay, so when they tell you that AB is 4, right? So let me just put in the sides for you. So this is A, B, C, and they give you D, E, F. Okay. All right. So when they tell you that AB is 4, okay, well, you know it's midpoint, so we could split a 2 to 2. Okay. But what you also know is if this is 4, the one parallel to it, right, which is here to here, has to be half. So that also has to be 2. And when they tell you that AC over here is 8, right? This whole thing is 8. Again, I know the one parallel to it has to be half, but I also know that these pieces are also 4 and 4 if I want to throw them in there. And when they tell me that BC is 10, the parallel side must be 5, okay? And all of these will be 5. Okay, so what you end up with is they want the perimeter of DEF right here. Okay, so here the perimeter just ends up being 11, okay? But again, I didn't really have to find all 3 sides because I could see that the big triangle has a perimeter of 22. So I know the little triangle has to have a perimeter of half of that, which is 11, okay? All right. Now, area speaking, by the way, if they ever ask you a question about area, this little triangle, do you see, would not be half the area of this because you actually get 1, 2, 3, 4 of these little triangles. So actually the area would be 1/4 the area of the big triangle. Okay, last thing, guys, okay, the right triangle proportions. Probably one of the more confusing parts of this unit. I would say that tends to be where most of the questions come from. So that's where I want to finish up. So with the right triangle proportions, all right, let me start with a fresh page so I can really explain this to you guys, okay? With the right triangle proportions is if you have a right triangle, and honestly, it doesn't matter which way you draw it, okay? Usually we draw it like this for some reason. If you have a right triangle, and inside that right triangle, you drop an altitude, okay, straight down. And you guys know by definition of altitude, you just get a perpendicular line. So what you end up with are 3 right triangles, right? So we have our triangle on the left is a right triangle. The triangle on the right is a right triangle, okay? And then we already know the big guy is a right triangle, right? Okay, so what ends up happening is technically all 3 of these triangles are similar to each other, okay? And the reason why they're similar to each other is because they each contain a right angle, so you already know it has one angle congruent, and they each share an angle, okay, when you're going side to side. So again, I could do a proof of it for you, okay? But really we can just, there's kind of a trick to remembering the proportions that happen, okay? So that's what I'm gonna explain to you right now. Okay, so let's start with the first example. So the first types involve, okay, so again, I'm just gonna redraw the picture, okay? It involves the 2 little triangles, the left triangle, the left-right triangle being similar to the one on the right, okay? Now, you know the proportions would involve that one. So if like we're looking at the examples on page 17, okay? So the very first example, okay? I'm gonna draw that, number 1 on page 17, okay? I have a triangle A, B, C, with altitude CD drawn. Okay, so they give you that AD is 3, they give you that dB is what we're looking for, and they give you the altitude is 6. Okay, so I know this one involves the left and the right similarity because I'm given the shared side between those, right? So if you're talking about these two triangles being similar to each other, they do share a side, right? So I know it's that proportion because I'm given a side that's shared between the left and the right triangle. So the easiest way to set up the proportions in this case, okay, when it's this one, okay, so when it's up here, I'll put it up here for you. Okay, so when you're given the altitude is the shared side. So the altitude needs to repeat itself in both proportions. Okay, but they repeat on the diagonal because actually the way these two triangles correspond to similar, they're actually turned. So, excuse me, it is not the 6 of this triangle corresponding with the 6 of this triangle, but that's okay. You just have to remember that the altitudes go on the diagonal. Now, the other two sides you put in should be the other two legs of the two left and the right triangles, which is what I have, right? Do you see I have part and I have part? Okay, if for some reason they gave me part and whole, I would have to subtract because the two sides that go with it have to be a side of this triangle, it doesn't matter where I put it, and a side of the triangle on the right. So that's it. So in any altitude problem where you're given the altitude, you're going to go altitude, altitude, and then we could call this segment 1 and segment 2 of the hypotenuse, of the larger hypotenuse. So all you have to do is put the other two parts. So a segment and a segment. So it always looked like that. So in this case, 3x is 36, x is 12. Okay. So another one that would be like that is number 3, right? So let's look at number 3 for a second. It says an altitude divides the hypotenuse into 2 segments. Great. Okay. If the ratio of the 2 segments is 1 to 9, now remember with ratio problems, we just tack on an x. So we make this 1x and we make this 9x. Okay. And it says the length of the altitude is 6. So again, same thing we have going on here, right? So as soon as I see that the shared side is between the two littles, I'm going to put that shared side on the it doesn't matter which diagonal. I could have put it on the other diagonal. And then the 2 segments, any order, go on the other diagonal. So I get 9x squared is 36. Divide by 9, I get x squared is 4. And here I get x is 2. Okay, so that's one type, right? So if you're given the altitude, it's going to be an altitude, altitude, segment, segment. Okay, now that's not the only proportion you could be given. Okay, we could also, okay, so once again, let's go back up to here. So I have this and I have this. Okay, so now if you look at number 2, okay, so number 2 is the same picture that we just had, A, D, B, okay, C, okay, and you are given, so on this one, you are given that AC is 4, you are given that AB is 8, and you are asked to find AD. Okay. All right, so now this one is a little different because you will see it doesn't involve the altitude at all. So if it doesn't involve the altitude, it's not a left to right similarity. What it's going to be is one of the smaller triangles to the whole triangle. It's small to whole. Okay, so this proportion is going to involve either the left triangle and the whole or the right triangle and the whole. You can tell which one it is because it just depends on which one do you actually have sides for. Do you see all the information we have is about sides of the left triangle? So this is going to be a proportion that involves the left triangle corresponding to the whole triangle. Okay, so here's what you would do. Right? So again, if we're still, so in general, we're going to set up a proportion here, but for number 3, right? So this is our information for number 3. Now, once I determine it's the left triangle to the whole triangle, again, same thing as the other one. They share a side. The left triangle and the whole triangle always share one of these sides. In this case, the side they share is AC, right? But again, AC in the little triangle is the hypotenuse. AC in the big triangle is a leg. That doesn't matter. That's the shared side. So if 4 is the shared side, that goes on one of the diagonals. So in this case, the shared side is going to be a leg. We'll call it the original leg. Okay, but this again, it's not, I mean, you could call it a leg. You can just remember that this is whatever is shared. Okay, now the rest of the proportion involves one of the segments and the whole hypotenuse. So before it was segment to segment, right? Because again, it was little triangle to little triangle. Since this proportion is the little triangle to the whole, it only involves one of the segments and the whole hypotenuse of the original triangle. Okay, so again, it doesn't matter what order I put it in, right? So again, one of the segments that I'm looking for, that's perfect. It's in that triangle is X. The whole hypotenuse is 8. So I have segment of the similar triangle to the whole hypotenuse. So here I get 8x is 16, x is 2, and I'm done. Okay, so it just depends which triangle you have, okay, which one it is you're looking for. So in number 4, if you look at number 4 describes a picture where you have a right triangle with a hypotenuse drawn, okay, and it says the segments formed by the altitude are 8 and 10. It really doesn't matter if you put them in the right spots, it's fine. Okay, and then it says, find the length of the shorter leg of ABC. Okay, so let's just start with that, the shorter leg of ABC. So again, none of my information is about the altitude. So this is going to be a small triangle to a whole triangle, right? Now, again, because all my information is about the triangle on the left, I know I'm using the triangle on the left to the whole. So the shared side between those is the X side. So again, just make sure you repeat that X. Okay, so the X is shared between this little one and this big one. Now again, you have to have one of the segments and the whole hypotenuse. Now if it's between the 8 and the 10, we are going to be using the 8 segment because that's actually in the triangle that we're using for similarity. Don't forget you need the whole, not the 10. You would use the 8 and the 10 if it was the altitude you were looking for. Since it's this I'm looking for, it's the 8 and the whole, which is 18. So here I have x squared equals 144, x equals 12, okay? Now it says find the length of the longer leg. So again, same triangle with an 8 and a 10 split, okay? But this time, let's call it Y. I want the longer leg. So again, same thing. Doesn't involve the altitude. So again, it involves one of the smaller triangles and the big one. But you see this time it involves this triangle on the right and the whole. So the shared side between these two triangles is the Y side. So that has to go on the diagonal. Okay, and again, I need a segment and a whole. This time, because the Y and the 10 are in the same triangle, it's the 10 segment I'm going to use, but it's still the whole. So on this one, when you cross multiply, you get 180. It did say to write it in simplest radical form, so 180 does break down into 36 and 5, which gives us a final answer of 6 rad 5. Okay? All right, guys, I hope that clears some stuff up. Okay, so right now, with any remaining time that we have, you can chat in some questions. You can just kind of process this and wait for questions when we have our, we are going to be class 1 in our support lab. Okay, so again, for that would be, let's see, well, I'll follow up with you guys on that. Okay.